Hello people, I'm Bharat Acharya. Welcome to our new video. So in this video we're going to see LCD interfacing with 8051. You see LCDs everywhere. I don't need to tell you how useful they are. Even your calculator you see it. Toll stations, somewhere inside trains where you see the next train on the next station, etc. Those displays. They're all LCD displays. Now an LCD display can be a static display, can be a scrolling display, can be a vertical scroll, can be a horizontal scroll. The scroll may go from left to right, right to left. Even a static display can be left aligned, can be right aligned. So there are various ways in which the display can be configured. That's why you don't connect a display directly with the processor. The display comes with its own controller. Okay, so it's an LCD display with controller. You give this controller various commands which I'm going to teach you. By those commands you decide what kind of display you want, and then you give the data that you want to display. Suppose you want to display A as an example. You don't send A, you send the ASCII value of A. So suppose you want to display a message called hello world as an example. We do this program all the time in the class, and this came in the EXTC paper 2 days back. The message to be displayed was hello, not even hello world, it was just hello, binary. So suppose you want to display hello world, you make a lookup table containing ASCII codes of all these alphabets. Please remember to include the space also. Space also has an ASCII code, otherwise it will come down as a single word, hello world. Anyways. So, you create a lookup table. One by one we take values from the lookup table, go on sending it to the display. It will go on displaying it in the way you have decided to display it. Okay, so that was the introduction. Let's start. The first thing, let's understand the interface. The interface is very simple. There are 14 pins on the LCD display. 1, 2, 3, 4, 5, 6 and the 8 pins carrying data. Okay, so it's a 14 pin connector. 2 pins are VCC and ground. I don't need to explain this to you. VEE. This is your brightness control. Wherever you tap this, that will decide the brightness of the display. Like in most displays, like your mobile phone, you can adjust the brightness. So that brightness control is over here. Then there is something called RS. RS stands for register select. Now what did I tell you 5 minutes back? You send commands to this display to decide how it's going to work. You also send data, which is the data to be displayed. So both the things, data and command, are given through the same bus. So whether it is a data or a command is decided by the signal called RS. RS stands for register select. RS can be 0 or 1. Listen carefully. If RS is 0, that means you're sending a command. If RS is 1, that means you're sending data. First you send commands. So default value of everything is 0. That's why it's kept like this. So the default value is 0. The first thing that you'll be sending is a command, because obviously first you'll decide how you want the display to be. Then you'll start sending data to actually display the values. So first you keep RS0, give your commands, then keep RS1, send your data, and the data will be displayed. R/W bar, read or write. 1 means read, 0 means write. I'm sure you're wondering if it's a display, obviously we're just going to write. Why would you want to read? You are absolutely correct. You want to write. But if you want, you can also read back what you had given, especially commands. If you're given a command and you decided how the display to work, and you've done that numerous times and you lost track what is the last way you have decided the display to work, you can always read it back if you want to. We won't do it in our program, but just telling you why that signal is there. We will always keep the signal 0, we'll always be writing. Now, whether you send a data or a command, you have to latch it. Just like the A to D converter, you need to latch it. So latch enable should be turned 1 and then turned 0. This action latches whatever you send. It captures whatever you send, whether you send data or command. So that was the interface. I hope you understood the interface. I'll go through the pins again. Ground, VCC, brightness control, register select to decide whether you're sending data or command, R/W bar to decide whether you're going to read or write. We will always write. And latch enable to latch whatever you send. So these are 1, 2, 3, 4, 5, 6 and 8 bits of data or command. 6 plus 8, 14. Then those are your 14 pins. We've connected these individual lines on port 1 and we've connected the data command line on the whole of port 2. Then it's the entire port 2 because it's 8 bit. Now, these are the commands that you have to send. Okay, first of all, let me tell this to you. Many people think this is a very tough interface and you're going to spend a whole day learning it. That is rubbish. By the time this video is over, you will pray this comes in your paper. Okay? It is very simple. Second, 95% of things written on the board do not change no matter what is the question. Because get this clear, what you want to display has nothing to do with how to display. This program is about how to display. What you want to display is a very small factor in the program. So if you want to display hello or happy new year or happy Diwali or merry Christmas or something of that sort, just the count of the alphabets is the only thing that will change in the whole program. So get this program. If it comes and you haven't studied it, you'll be kicking yourself because everybody else would be attempting this. Okay? Because it's something which is so simple, it is bound to give you full marks in the exam. Now, these are your command values. There are numerous commands that can be given. If you take the whole data sheet of a display, you will see there are numerous commands to decide how the display should be working. We have taken one particular orientation. So, the first command 38 sets it up as a 2-line 5x7 matrix display. 2-line as in the screen pixels will be divided into 2 lines, so you'll have 2 rows of display, and each character will be formed by a combination of 5x7, 35 pixels, 5x7, 35 pixels. So do you understand? It has so much more resolution than a 7-segment display, where you have only 7 elements to form a character. Here you have 35 elements to form a character. So you can form complex characters like S or W or M, etc. Excuse me. So first of all, you set up the display, then you turn the display on. Now, don't try to memorize this, understand it. What are you going to do first? First you will turn it on, or first you will set up? Obviously first you will set up. How can you turn it on and then decide how you want the pixels to be aligned? What sense does that make? Once you turn it on, whatever was the previous setup, it will work on that setup. It won't even accept your new setup. So first you set it up, then you turn the display on. Now again, there are various types of commands over here. One of them will only turn on the display, one of them will turn on the display and turn on the cursor. One of them will turn on the display, turn on the cursor, but not blink the cursor. So I have chosen the one display on, cursor blinking. Then again, you can take the data sheet and play with it and have different kinds of it. Some displays don't like a cursor blinking, some displays like a static cursor does, some displays don't like a cursor at all. So that depends upon how you want to arrange your display. So I've chosen this one, display on, cursor blinking. 0, 1, clear the display. Again, it's a very logical thing. What are you going to do first? Turn it on or clear it? Obviously turn it on. If it's not on, what are you clearing? So first you set it up, then you turn it on, then you clear the display. Is clearing necessary? Yes. Otherwise, any previous garbage that was displayed, that will still be there on the screen. That's what you don't want. So clear the display. Now, you are about to start displaying. You're going to choose whether you want it to be right aligned or left aligned. Text, it's a universal notation. Text is left aligned, numbers are right aligned. It can always be different. There are some beautiful languages which work the other way around. My mother tongue is Sindhi. Sindhi is written the other way around. So, yeah. Anyway, but normal English textual display follows this notation. Numbers are right aligned and text is left aligned. So, I've chosen left aligned. Left aligned is also called cursor increment mode, where your display will go from left to right. So that for that the number is 6. In case you want to right align, give the number 7, 0, 7. As I said, there are lots of different commands that can be given. I have chosen one particular way to display, the most standard way of displaying it, of course. Then 80 is cursor home command. Now these two are very related to each other. When you give cursor home, it goes to line 1, position 1. Now what is position 1? The rightmost position or the leftmost position? That depends upon whether your display is right aligned or left aligned. If it is left aligned, then it's the leftmost position and vice versa. That's why it is necessary to first give the increment mode and then give the home command. Are you clear? So did you understand the sequence? Let's go through the sequence again. First thing, you set up the display. Second, you turn it on. Now clear the display so that the garbage is wiped out. Now choose your alignment. And then finally give the home command so that after choosing the alignment, it should not start displaying from the middle, from the last left cursor position. It should start from again right from the beginning. So give the home command so that it starts from the beginning. Please tell me, do you understand? So these are a set of commands. The numbers you got to memorize, but I've given the logic behind it. Those are numbers. There's no logic behind numbers. Numbers you just have to know. 38, 0, 01, 606 and 80 are the numbers. Now, there is a procedure of giving a command and giving a data. Both procedures are 90% same. There's only one thing that changes. You already know it. Suppose you want to give a command. This is your procedure. Put the command on the port. Make register select 0 to indicate that you're giving a command. Make RW 0 to indicate that you want to write. Latch enable, make it 1 and then make it 0. By making it 1 and 0, the value is captured. Now, whatever command or data you give, remember you are not directly dealing with the display. You are dealing with a controller which in turn will set up the display. That takes some time. The time varies from different products that you have bought, different manufacturers. It goes anything between 5 to 10 to 15 milliseconds. I have taken the most standard one, 10 milliseconds. So whether you give a command or you give a data, see to it that you call a delay of 10 milliseconds. I am saying this again. You are not directly working with the display. You are working with the controller which in turn will set up the display and will do the appropriate action. That takes time. So to be safe, you give a delay of 10 milliseconds. 10 milliseconds is too small for a person to notice. It happens 100 times in a second. A second has 1000 milliseconds. So it's 1/10 of a second. So it's something that nobody will notice, but it is required for the display to work. So when you want to give a command, these are the steps. Put the command on the port. Make register select 0 to indicate that it's a command. Make RW 0 to indicate that you want to write. Make latch enable 1 and 0. and then give the command or give a small delay of 10 milliseconds so that the action takes place as per your command. Exactly same steps to give data. Put data on the port. The only difference is now make RS1 to indicate that it is data. Make RW0 to indicate that you are writing. Make latch enable 1 and 0 so that it's latch, and keep a small delay of 10 milliseconds. That's same. It's exactly the same except for RS being 1 and RS being 0. That's the only difference. Now, keep a lookup table. Let the lookup table start from some location like 0400. Initialize DPTR at the beginning of the lookup table. Now every index, suppose you want to display hello world, your first index will be 0. So initialize A with 0. Move CA comma at the rate A plus DPTR. I'm sure you know this. If you don't know how to work with the lookup table, please check out the video on addressing modes. This is towards the end of the subject. You cannot directly see this video without knowing basics of the subject. Okay, so check out the video on addressing modes. I have taught how a lookup table works. So keep the first index as 0. You will get the code of H displayed. Then increment the index and go on accessing all the codes hello world, and you can display all of them. You can even play with it. You can start from the last one and get it all opposite. Anyways, you can get alternate characters. Then again the next set of alternate. That's your creativity. I'm teaching you how to work with the display. How creative you are, that's in your hands. You can do a lot with it. But that's all fun for practicals. From theory exams, stick to basics. Hello world is how you'll be displaying. Now, this is your program. Initialize DPTR as a pointer to the lookup table. Now, first thing you're going to do is initialize your display. Give those 5 commands 38, 0F, 01, 06, 80. Okay? Now, how do you give every command? There is a procedure which I just taught you. Give the command, make RS0, make RW0, make latch enable 1, then latch enable 0, and call a delay. Now, you understand you need to do this procedure 5 times for all the commands. You're not going to write it 5 times. So make another function, a subroutine by the name command. It will give any command that is present in A register. Put the command in A register. See the first one. Understand the first one, you understand all. Move A comma hash 38. So your first command is 38. Move P2 comma A. So you put the command on the port. Clear P1.0. That means you made RS0. Clear P1.1. That means you made RW also 0. Set P1.2, clear P1.2, that means you've done the latching, call a delay of 10 milliseconds and return. This was the procedure done to send 38 by calling a subroutine by the name command. Now all the commands are given in the same way. Just put the command in A, call the routine. Command in A, call the routine, etc. etc. So 38, 0F, 01, 06, 80 are the commands which you put in A register one by one and call your command routine. Tell me, did you understand this? Done. Just like we have made a procedure to send a command, we have made another procedure, a subroutine to send data which is identical to this except for this line. This line will be set P1.0 indicating that you are sending a data and not a command. Again the same thing, whatever data you want to send, that is the ASCII code of that alphabet. Put it in A register and call this routine, it will send it. So all I need to do in my main program is get the ASCII code of HELLO space WORLD into A register one by one. How do you do it? Using a lookup table. How many alphabets you want to display? Let's do a count. 1, 2, 3, 4, 5, space is 6, 1, 2, 3, 4, 5. That is 11 alphabets. So you're going to do it in a loop with a count of 11. 11 is B. So move R7 comma hash 0B. You're seeing this is written in pink color. I hope you can see the color. That's because this is the only thing that will change on the whole board no matter what you want to display. So move R7 comma hash 0B. You understand how simple this is? This is the only thing that will change on the whole board. No matter what is the question, this is your answer. Move R7 comma hash 0B, that's your count. Your first index is 0, so you take it in R0. Move A comma R0, so A becomes 0. Now students say how stupid. First you put 0 in R0, then you're putting that R0 in A. You rather put move A comma hash 0. No, my friend. If you write move A comma hash 0, how do you put it in a loop? Every time it will be 0. Here we are taking the value from R0. In the loop, I'll go on incrementing R0. So first index will be 0, next index will be 1, next index will be 2. Please tell me, do you understand? The basics of programming. I'm sure you've done some programming before you reach here. So move A comma R0. So A gets the value 0. Move C A comma at the rate A plus DPTR. DPTR was 0400 plus A, which means 0. So 0400. From 0400, you'll get the code of H. That code of H has come in A register. That has come in A register. Are you listening? This is the ASCII value of H. This is what you want to display. Call the routine by the name data. It will display whatever is there in A register following the same procedure. So on the screen, by now on the screen you have got an H. Increment R0, your index in the lookup table. So R0 was 0, it has become 1. put this procedure in a loop with a count in R7. R7 is 11, so this procedure will happen 11 times. So first you will get the code of H, then E, then L, then L, then O, and you will display it. If you want to make it a little more creative, keep a delay, a visible delay of let's say half a second somewhere inside this loop. So your hello world will not come together, it will come as H, E, L, L, O. You can even play with it, keep the delays big in the beginning and then lower, lower, lower. You can use your creativity and display it the way you want. Anyways, so when this loop is over, your display is done, job done. These are your command routine and data routine. Now your lookup table. Either you can assume that there is a lookup table, most examiners are happy with that. If your examiner is very strict and if you have a feeling that they like to cut marks for, even if you miss out on one small thing, make a lookup table. Instead of contemplating whether I should make or not, just make it. It's so small, 2 lines it takes. ORG 0400. ORG 0400 means you are giving ORG equals origin. Whatever is the address you want to keep for the lookup table, you choose the address. So whatever address you want to keep that address over here. DB, define byte with a quotation, write hello world. The moment you put anything in quotation, assembler substitutes its ASCII value. So assembler will substitute the ASCII value of all these alphabets, and that's how you create a lookup table. Now you tell me what will change in your exam. Suppose in your exam they say display, write a program to display Happy New Year. HAPPY space NEW space YEAR 14. 14 means E. This number will be E, 0E. That's all. Your lookup table will be Happy New Year, and here you will be writing EB quotation Happy New Year. That's all. The display. What you are displaying has nothing to do with how you want to display it. This program teaches you how to work with an LCD. Once you know how to work with an LCD, display what you want to. Are you clear? I hope you understood it. All the best.